Hello and welcome. Now in some series of video we will be learning what is VPC, Virtual Private Cloud. And a disclaimer, there will be a lot of networking. So if you have not done basics of networking session previously, then check the video again and go through it. We are going to revise some concepts from there, and we will be also learning about subnetting before we start VPC. So to understand VPC, we'll go back little in time when there was just cloud computing started. AWS came up with SQS, S3, EC2 service, classic EC2 classic. So we had data centers and we still have data centers. So in the data center network, there are so many components, networking components. There'll be switches, routers, firewalls. There'll be many networks. In those networks, there'll be smaller subnets. Subnets, the part of network is the subnet. And a subnet could be dedicated to probably a project or a front-end services running in that project, or another subnet for running back-end services for the project. Some have too much security, some are open to the internet. There could be network access control list to decide what traffic comes in, goes out, deciding the network scheme, what will be the IP addresses. Everything is in the control of networking team who is designing and managing networks in corporate data centers, in huge data centers, or even in small data centers. Now, when AWS came with its EC2 service, that was amazing. We were able to launch virtual machines on AWS or Amazon data center, right? And we can use it for computing. But then people wanted more on the networking. They wanted to decide their own networking scheme. They need to control what traffic comes in, what traffic goes out. So these things were not available in initial versions of EC2. So AWS came with VPC, Virtual Private Cloud. You can build your own network in your account in the region that you selected. You can decide the IP addressing schemes. You can decide on public networks, private networks. You can distribute your subnets into multiple availability zones to achieve high availability, and all those amazing concepts. So what really is VPC today? Well, its long form is Virtual Private Cloud, and it acts like that. You can create your own logical data center in a region, and you'll have complete control on that VPC. Think of this as a local area network that you are designing. So whatever you need in that, the IP scheme, the securities, the firewall, you'll have complete control on that. Like that, when you create a VPC in a region, your own, you have complete control on that. Once you have the VPC laid out, then you can start launching instances in that, RDS. There are so many, majority of the service in AWS that depends on VPC. So every region will have a default VPC. So far we are using default VPC, but when you create your own VPC, you get more control over it. So on a public cloud platform, you are creating a private network, your own private network, and you will have complete control over it. You can select the IP range, subnets, you can set up routing tables. That sounds interesting, and that's actually the first thing when you get an AWS account. Before you create your infrastructure, you do the network layout, you do the network designing and then layout, and then you start using it. Then you create your instances, your databases, your storage in that. We'll go get into that, we'll do all that, but first, for people who does not have basics knowledge in networking, as I recommended, go through the basics of networking video once again and then come back and join this video. I will take some basic concepts of networking first, and then we'll start creating our VPC design. So revising from basic networking, IPv4, we're talking about IPv4 now. We'll understand IPv4, subnetting, and Cider notation. So what's an IPv4 address? What we see IP address by running ipconfig or ifconfig command, we see the IPv4 address. That's actually the decimal number or decimal representation of binary number. IP address is 32-bit binary number divided into 8 octet. Octet because there are 8 binary numbers in every octet. So 8 plus 8 plus 8 plus 8. So 192 binary is 11, and then 6 zeros, then 168 binary number, 100 binary number. So whatever number you see in the decimal, it is derived from the binary number. And this total 32-bit. We have 4 octet, first octet, second octet, third octet, and the fourth octet. So when I say, when I'm referring to an octet, right, I'm saying third octet, fourth octet, you should know what I'm really referring to. The entire IPv4 range starts from 0.0.0 and ends at 255.255.255.255. I guess I said it 4 times. Okay, so you pick up any IPv4 and you will see that it belongs to this range. Now it ends at 255 because that's a binary number. Starts at 000. Its binary conversion is this 80s.80s.80s.80s. So 0.0.0 is the decimal representation. Now the last number in every octet is all 1. Right, so you have 81s.81s.81s.81. That's the last number in the octet, last binary number. And if you convert that to decimal, you get 255. That's why every octet you will see ending at 255 and not at, let's say, 999. You will not see any IP address like that. Now this whole IP range is divided into 2 parts. You have public IP and private IP. Public IP is for the internet. Every server, every computer on the internet will have a public IP, and that IP will be unique. So from that whole range, one part is given for the public IP, for the internet. The other part is for private IPs. So you can create your own network. Like internet is a network, you can create your own network. And for that, we have private IP ranges. So we're going to talk about private IP ranges. So you have class A. Range starts at 10.0.0.0, ends at 10.255.255.255. So if I take an IP address 10.16.250.120. Okay, this IP is a class A IP. Right? It comes in that range. Okay. Likewise, class B 172.16.0.0 starts there, ends at 172.31.255.255. So taking another example, let's say 172.16.25.10. This is a class B IP. Some other examples, 172.20.254.12. So that's class B, okay? So 172 first octet is going to be same. Second octet can be from 16 to 31. Okay. Then third and fourth octet can start from 0 and go till 255. So that's class B. Private class B. Now if I say 172.32.25.65, that is not in the private IP range. This is a public IP. Okay. Let's see class C, the famous one. 192.168.0.0 starts there, ends at 192.168.255.255. So first 2 octet will be same. Third and fourth octet can be from 0 to 255. Okay. So these are 3 private IP ranges which you can use. There's class D and E also for research and multicasting. We don't use them. So when you create a network layout, you're going to select class A, B or C, and then you can, whatever class you select based on your requirement, and then you can divide it much more further. Okay. The way we divide is by using subnet masks. So I'm going to talk about classful subnet mask 255.0.0.0 and 255.255.0.0 and 255.255.255.0. Now, what really is subnet mask? Like IP address is the address of that network interface. Subnet mask will decide on the network that an IP address range starts at what IP, ends at what IP. How many IP address do you get from the range? What will be the network address? What will be the broadcast address? All these things are decided based on the subnet mask. So let's take an example. I'll take my own computer IP. So I'll open command prompt and I'll run ipconfig. Okay, I see IP address 192.168.0.174 and subnet mask is 255.255.255.0. Okay, let's take this example. So let me open my notepad. Okay, so that's my IP and my subnet mask is 255.255.255.0. Now this is class C private IP. Okay, that you should have been understood by now. So this IP is assigned to me by my Wi-Fi router, which has a DHCP service. It's allotting IP addresses, and from the range, it has given this particular IP address. So the DHCP server is given this subnet mask and the network range. Okay, 192.168.0.0, 255.255.255.0. Now this is given to the DHCP server. So DHCP server has this range and it is going to allot IP address from this range. Now how is it a range? Well, the subnet mask decides that. First 3 octet is full. So this is your network address, network part. Okay, this cannot be, changed. 192.168.0. This is your network address or network part. The one that is 0, the last octet is 0, that is your host range. So you can allot IPs from this range. Think of this as the street address and this as the house address, right? So in the street address will remain same, right? But the house, you have house from 0 to 255. You can have 256 houses in that street, right? So the first house address will be 192.168 first 0.0. Okay, that's going to be the network range, network IP. The first address can be assigned to the house 0.1. Okay, like that 192.168.0.2, right? Like that, so on and so forth. It can go till 192.168.0.254, and then the last one 192.168.0.255. That's it, it ends. Okay, that's the first IP, and this will be reserved for the network. Okay, that's, you cannot assign that IP to any network interface in this range. This is going to be the network IP. Okay, also the last IP will be reserved. This is for broadcast. And all these other IPs that we see, this range is usable. You can assign it to the system, okay, to the network interface. So you can say this is the first usable IP. Okay, that is the first usable IP. You can assign it to a network interface. And this is the last usable IP. Now, how did we know all that? Well, we know because of the subnet mask. So based on subnet mask, we got to this conclusion. Since 3 octets are full, first, second, and third octet is full, so this part is not going to change. This is the network address. The last octet, the 4th octet, is going to change. Okay, it will start from 0 and go till 255. So that's what subnet mask does to a network range, right? So if we say total, how many IPs we get if we use that subnet mask? Total IP we get is 256. It starts at 0. Okay, but total usable IP that you can assign, so minus that with 2, right? 254. Okay, because the first IP and the last IP is reserved. First one is for the network, the last one is for the broadcast. Right, so if any broadcasting needs to be done on this network, it will be sent on this IP address and it will be heard by all the network interfaces in this network. That's broadcast. Like, you have like TV broadcast or radio broadcast, where everyone having the same devices, gets the same data. Okay, that's good. Okay, now let's take another example. I will take a class B IP now. 172.16.12.36. Okay, taking this IP address, some random IP, okay? And doesn't matter whether I take class B or class A or class C. That doesn't matter, okay? The important thing is the subnet mask. Okay, now based on our previous experience, we can say the first two octet, first and second octet is for the network. So 172.16 is for the network, and the last part you're seeing 12.36, that is for the host. So that is your host address, and this is your network address. Okay, now, so where does this starts? 172.16.0.0, that is the first IP. 172.16.255.255 is the last IP, right? And we know first and last IP is for, first one is for the network reserved, and the last one is for the reserved for broadcast. Right, so first usable IP 172.16.0.1 is the first usable IP, right? And then the last usable IP will be 172.16.255.254. Okay, check there. All right, this is the last number in the octet. So third octet starts from 0, goes till 255, and the fourth octet is going to be, cycling from 0 to 255, then again it goes from 0 to 255, again from 0 to 255, like that. So this is the last usable IP. Okay, now if you still did not get it, okay, let me give you a few more. Let's give a few more IP addresses here. Okay, so 172.16.0.2, that's the second IP, right? 172.16.0.3, that's 0, 1, 2, 3. Yeah, that's the fourth IP, right? Or third usable IP. Like that, it is going to go on and on till 172.16.0.255. Now, does it end over here? No. The third octet also changes. So 172.16.1.0, sorry, 1.0, and then 172.16.2.0, right? Like that, so on and so forth. That also ends 172.16.2.255. Does it end? No, it continues now, 172.16. So as long as the third octet is not 255, it will keep going on. Okay, the meter keeps going on. So you can say 3.0. Right, so that's why I said 0 to 255, right? 0.1, 0 to 255. Then again it starts 1 to 1.0 till 1.255. Yeah, to fix this, 170.16. Oops. 16.1.1 and 172.16.1.255. Right, so like this it goes on and on. So total, how many IP we get from this? Total IPs. Right, so we can do multiplication. 256 multiplied by 256, that is somewhere around 65,000. Wait, let me do the math. 65536. No, that did not come instantly. I used the calculator. Okay, so that many IP addresses we get if we are using this subnet mask. Right, but that's a big network. We don't use it like the whole at once. We divide it into smaller subnets. So we can say 0.0 is one subnet, then 1.0 is another subnet, then 2.0 is another subnet. Like that, I can have 256 subnets. Okay, so let me just write that down, subnets. Okay, so if I take each subnet of size 256 IPs, right? So then I can have 256 subnets. Right? That could be my first subnet, that could be my second subnet, that could be the third subnet and fourth subnet. Like that, I can have 255 subnets. But I'm specifying the size here. I'm saying each subnet is of this size, 255.255.255.0. Okay, so you know what that does, right? First 3 octet is full, and the last octet change. So every subnet gives me 256 IP address. Minus that by 2, 254 usable IP. Right, so like that, I can have 256 subnets if I have this as my main network address. Okay, so it's a huge network, but we have one more classful. Let's take example 10.23.12.56 subnet mask 255.0.0.0. So we know now only the first octet is for the network. The other 3 octet that we are seeing is of the host. And so first IP will be 10.0.0.0. Last IP will be 10.255.255.255. Okay. 10.0.0.1 first usable IP. 255.255.254 is the last usable IP. Right, so total IP 256 multiplied by 256 multiplied by 256. Right, you can do the maths. Okay, so that's total number of IP address if we use this subnet mask. So based on your need, you are going to select a subnet mask and the class of IP. If you want, you can divide it much further. So I will take one example now. I will take the class BIP 172.20.0.0 and I will take subnet mask 255.255.0.0. Okay, and that I'm going to divide it into smaller subnet 172.20. I'll start with 1.0. Okay, 1.0 172.20.2.0 and each of this subnet will be size of 255.255.255.0. Okay, now since we are here, let's talk about the Cider notation. Okay, let me clear this and let's talk about Cider notation first. CIDR, classless internet domain routing, what it is. Well, we know 255.255.255.0. If we convert it into binary, what do we get? 1 2 3 4 5 6 7 8 dot. Let me just copy that. Dot 1 2 3 4 5 6 7 8. Okay, so that's the binary representation of this subnet mask. Right, let's write all of that. The other 2 subnets also I'll write. Okay, 255.0.0.0. So we have 1 2. I'll copy dot. Okay, another one 255.255.0.0. So that's decimal. This is binary, right? For all these 3 subnet masks, we have decimals and binaries. Now, if you count the number of 1, how many 1 we have here, right? In this subnet mask, that's 8. Okay, 8. So your Cider notation will be /8. There, over here, how many 1s we have? 8 plus 8, 16. Right? Here, how many 1s we have? 8 plus 8 plus 8. So that is /24. Now a subnet mask can be represented like this. In the operating system, you will see subnet mask like this. In binaries, you will see like this. But now in cloud computing virtualization, we give in Cider notation format. So when I say /24, you should understand this means that subnet mask. When I say /16, that means this subnet mask. Right? So based on this, let's decide the IP addressing scheme 172.20.0.0 /16. What does that mean? That means First two octets are for network, the last two octets are for the host, right? And we can understand where does the first IP starts and last IP, all of that, right? Okay, and now I'm going to divide it into further smaller networks. So 172.20. I'll say 0.0/24. Okay, that could be my first subnet. 172.20.1.0/24. Okay, that could be my second subnet, right? Oops. Alright, so you know now how many subnets of /24 size I can create from this network. Total 256 subnets I can create. Okay, so I will give this as network range. These are as subnets. Okay, so by looking at an IP address and the range, you should be able to tell what will be the first IP, last IP, how many total IP addresses does it give, what is the network part, what is the host part. These are some questions you should be able to answer to yourself. If you still have doubt or you see a classless Cider notation, like, not 1624, maybe 20/18, if you see like that, or if you're still not confident on this one also, there are online subnet calculators. You can just Google online subnet calculator, right? Okay, let's pick up some, let's take this one. Okay, so you can give the IP address and you can give the Cider notation. It will tell you what is what. Okay, so let's take example 172.20.16.54. That is some IP from this network /16. Okay, let's calculate. Okay, so that's our IP. Net mask. This is the subnet mask. Wildcard. Wildcard is the opposite of subnet mask. Okay, wildcard will tell you about the host addresses. Network address, right? Broadcast address. Total, first IP, first usable IP, last usable IP, total IPs, right? It is even telling you that this is class B IP, right? If you don't like this site, you can try others. Just an example, there are many online subnet calculator. So get all these things what I explained straight. If you don't get it, watch the video once again. It's very important for you to understand the IP addressing and subnet schemes. If you know this, then VPC is going to be very easy to set up. So wrap this up, revise it, and join me in the next video.